Welcome, everybody. This is Using Nicer Programming Languages at Work. I'm Richard Feldman. So, I want to just start with a quick question. Have any of you ever introduced a new library at work? Show of hands? Okay, yeah, quite a few. What about like a whole new framework at work? Okay, so like not as many, but still a good number. And finally, how about a whole new language? I see some very happy, smiling people, but a smaller number of them. And yeah, so that's about what I would expect. I would expect most people to have introduced a library, fewer to introduce a framework, and even fewer to introduce a new language. And the reason I would expect this is essentially that library is a pretty minor commitment with pretty minor benefits. Like it doesn't take a whole lot to introduce a new library. It's not a big risk. And also, the benefits are not nearly as big as some of the other two. So this is kind of a spectrum. Like you have a minor commitment, minor benefits, framework, more of a commitment, and potentially more greater benefits. And then a language, the biggest commitment of the three, and then certainly the biggest potential benefits. So I want to talk about this third group because I think this is something that it seems to be the case that not a lot of folks have had experience with. It seems to be a lot more common because of the nature of the beast, the risks associated with them, the amount of commitment that it takes, that people have had more experience with the other two. And so this is a question that I get asked a lot because I've had some experience introducing languages to work, and people ask me like, hey, what's it like hiring people? What, how do you onboard people? Like, was it worth it? Is it, it's a big risk. How do you mitigate those risks? And also, like, what are the benefits? What are the concerns? What are the, trade-offs? So we're going to talk about all of those things today. And we're going to do those in the framework of kind of some case studies. So in particular, I'm going to focus on 3 companies, but I'm going to mention a couple of others. The first is WhatsApp, which has adopted Erlang, and they're sort of known for that. Not as popular of a language as perhaps it deserves to be. I'm talking about Go and how Iron.io adopted that. The little gopher logo. And finally, of course, Elm at Node Inc., where I work, and how we've adopted that. So we're going to talk about all 3 of these, as well as a couple of other companies, and talking about the different trade-offs and all those different things around hiring and all those things like that. So let's start with some benefits. So this is really, at the end of the day, like we got to hope that there's some benefits, some really substantial benefits. In fact, more benefits than we could get out of just a library or a framework if we're going to shoulder the costs and the risks and all the other stuff. So some of the benefits include reliability, productivity, and reduced costs. So let's get a little bit more specific about those. Reliability. So Erlang was created at Ericsson. This is a Swedish telecom company. And their flagship product was the AXD 301, as everyone knows. And it was essentially like 2 million lines of Erlang code. And this is basically what Erlang was built to do. It was built to be really great for telecommunications, like high availability stuff where error tolerance was really important and uptime was really important. If you think about it, how bad is it if you were to make a phone call and your system were to go down in the middle of that call and your call gets interrupted with, hang on, you need to restart to get the latest version of the software before you can finish your call. That'd be a disaster. So it needed to be like high uptime and also to be able to deal with things like, what if power lines go down? You need to seamlessly fail over very quickly without interrupting the user and ideally not even interrupting their call. There's just a lot of potential failure modes. And they wanted language level support for excellent error handling and fault tolerance. And they really got it. After 20 years in production, this system has had 9 nines of uptime. So if you're not familiar with that nomenclature for uptime, that is this percent uptime. I'm not even like 99.9999999%. It's almost never gone down. It's not that they've had 0 downtime. It's not like it's impossible for it to go down, but it's negligible. It has basically never happened. They've essentially had no downtime. It rounds down to 0. That's not something you can get from just introducing a new library. You can't just say like, we switched to like, I don't know, Erlang.js, and now, it never crashes anymore. It's cool. You really need like something fundamental to get this level of reliability, and they got it. We've also seen some great reliability benefits from our use of Elm. So this is a chart of our production runtime exceptions from the last 3 years since we've been using both Elm and JavaScript side by side. So this is the JavaScript side of the chart. This is rollbar is what we use to record errors in production. So whenever something crashes, something throws a runtime exception, rollbar catches it and logs it so that we can track it down and hopefully resolve the bug. So in the past 3 years, we've had about 60,000 JavaScript runtime exceptions. This is from mostly from our code, but some of this is also from like third-party stuff. Like end users have browsers with extensions and stuff that crash from time to time. But for the most part, as far as we know, this is our stuff. And then on the Elm side, yeah, there's no more to this chart. But we're done rendering it. It's not like literally no runtime exceptions, but it's so low that it's 0 pixels on the chart. Like it's like single digits, and it doesn't actually show up. So again, like not 0 runtime exceptions, but it was 0 for a while, but eventually it happened. But it's negligible. This is not something that we worry about anymore, and it used to be something that we dealt with constantly. I mean, just all the time. But now, like we ship new Elm code. The majority of our system is written in Elm. It's like 250,000 lines. That's not like there are 2 million lines of Erlang, but still, it's a ton of code. And it just basically doesn't crash. I mean, not literally never, but close enough that it's just not something that's on our minds anymore. And then finally, we have Facebook. So Facebook recently converted, over the course of the past year, they've converted about 50% of Messenger.com to use ReasonML, which is another ML family language like Elm. They're in this kind of similar space. And they did something that I wish we'd done, which is they tracked bugs before and after, like bug reports. So they used to get daily bug reports on the parts of Messenger that they ended up switching to Reason on. And after the switch, they reported that instead of getting daily bugs, they got 10 bugs total over the course of that whole year, among the code that they ported over. So that's like all they've gotten is just 10 instead of daily. That's a huge difference. And imagine the amount of time and effort that not only their developers have saved, but also that their end users have saved in terms of not having crashes, not having experience interrupted. That's a really big difference, and not something I think you can just get from a library or even a framework. Productivity. So WhatsApp, this is like one of the most mind-blowing statistics. When they had a staff of 50 people, they were supporting 900 million users. 50 people. That's like smaller than NoRed Inc. We have like 60 some odd. We do not have 900 million users though. Nowhere close to that. I mean, that's just mind-blowing. How are they able to do that with such a small group of people? I mean, just managing the server infrastructure, right? I mean, that's just got to be such a colossal task. But as we'll see later, they had some help from Erlang. Like they didn't need as much server hardware, as much of an elaborate infrastructure as a company that made perhaps different technology choices did. Mozilla with Rust. So how many folks have tried Mozilla's like rewrite of Firefox rendering engine, like the newer Firefox that's with the speed improvements? Okay, so this came from Rust, the programming language. That was what enabled this, and specifically it did because of confidence. So they talked about how they had these like really ambitious goals. They wanted to rewrite the rendering engine to make it more parallelized, and so that you could do like CSS in parallel with JavaScript and like various things that currently were sort of siloed and couldn't take full advantage of the processor. They're like, okay, we have these really ambitious goals, but we also have this like massive C++ code base that's really hard to maintain, and we just have like serious problem with ramp-up time on this thing. If we hire a new person, we don't trust them to make changes to our enormous code base until they've like learned the idioms inside and out and where they're supposed to use discipline and conventions to try and avoid breaking things. And what Rust got them was confidence, that they could say, we can get somebody ramped up on this project, we can go for these ambitious goals, and rather than having to rely on training and discipline and all the conventions that they were relying on, they could just get it out of the language. And they could get a systems programming language, which is what Rust is. Rust is sort of a potential replacement for code that otherwise needs C and C++ levels of performance. Rust can get that level of performance too, but it does so in a way that gives you a lot more guarantees at compile time. So you can have the confidence to tackle ambitious goals without this insane ramp-up time that they were dealing with. And then, of course, finally, NoRed Inc. We've had this sort of like fearless refactoring experience from Elm, like where we can just make these massive changes to the code base, and then once it compiles, it usually just works again. We had someone start, and her first week of the job, she made a pull request that changed 100 files. Now, there was no time for her to have known the code base well enough to know what the impact of that would be. But because we've had this experience with Elm where just if it compiles again, it usually just works, we were comfortable being like, yeah, we can safely merge this because it compiles. So we can just put it through to production. And sure enough, no bug reports as a result of that change. That's just a big change you can make with no fear of it causing regressions thanks to the language. Smaller decision trees. This is one of the quotes from my coworker, who he commented that one of the things he loves most about Elm is that whenever he comes to a fork in the road and he's like, I'm not sure how to proceed, or like I'm stuck, there's an error, something like that, the decision space is very small. There just aren't a ton of different ways for him to potentially proceed. And this is not just true at the library level, it's also true at the language level. The language is intentionally very small. In fact, the last several releases have actually removed features from the language. This is kind of like the opposite of Perl. Perl's philosophy is there is more than one way to do it. The cost of there being more than one way to do it is unfortunately that whenever you have a decision to make, well, there's more than one way to do it. So you have to think through them, even if there's not actually a big difference in productivity between the different options. Elm sort of like pre-boils that down for you, and so you can get yourself unstuck pretty quickly without having to spend a lot of time thinking about stuff that in the grand scheme of things doesn't really matter. And then finally, we've ended up writing fewer tests but getting more coverage, because the compiler just covers just a ton of stuff for us. We just get a huge amount of mileage out of this. Stuff that we used to have to write tests for to have any confidence about it, now we just don't write the tests, and the confidence is just there anyway, because the compiler is covering those use cases. We just don't have to write checks for them, because we already know that those things can't happen just because of the language that we chose. And finally, we talk about reduced costs. So Iron.io adopted Go when they used to have 30 servers. These are not pizza boxes, these are servers. When they used Ruby on Rails, and they switched to Go, and they ended up with 2 servers. Now, it's not just that they went from 30 servers down to 2 servers because they didn't need 28 of those. It's even better than that, because the only reason they had 2 servers was they were like, well, if we only have 1 server and it goes down, well, then we have nothing to fail over to, so we need a minimum of 2. And each of those is using like under 5% CPU. Like, so they're basically, the servers just went from being this huge expense for them, like a serious chunk of their operational costs, down to essentially trivial, and they've just got plenty of room left on those 2 servers by themselves before they ever need to buy a 3rd server. And all of that was from switching to a different language. WhatsApp, similarly, we referred to them earlier about their use of Erlang and how they had 50 people supporting 900 million users. Big part of the reason they were able to do that is from an infrastructure perspective, each server they have was at one point supporting 2 million connections. So for a real-time messaging app, that's an enormous deal. Again, think about the infrastructure costs of trying to do this with most languages. But Erlang makes it really easy. I shouldn't belittle it and say it's really easy, but Erlang is designed to make it as easy as possible to manage a system like this. And then finally, we have No-Red Inc. We've had the Elm package ecosystem versus NPM. And this has come up for us because every month, we have to go through and do monthly maintenance upgrades. So we just like routine package upgrades, security, stuff like that. We want to make sure we're using the latest stuff and not letting things drift too far out of date. In the Elm package ecosystem, semantic versioning is enforced. So what that means is if I publish a package, version 1.0, and then I make a breaking API change, like I delete a function, or I delete an argument from a function, or I change the type of something in there, and I try to publish that as 1.1 or 1.0.1, the package manager says, no, that's a breaking change. You have to bump to 2.0, or else you can't publish this. And it's just enforced across every package. So what that means is when we go to upgrade a package, it's very easy to see where the trivial upgrades are going to be. I can just say, oh, well, these are all minor upgrades, and I know they're actually really genuinely minor upgrades. Sure, anytime you upgrade a package, there can potentially be new bugs introduced. That's fair. But from the perspective of things still working together, I can have this huge level of confidence that I can just like be like, yep, upgrade all of those, and then it's just going to compile again, and they're all going to work, again, give or take, maybe implementation bugs. But with NPM, totally different story. I mean, they don't enforce semantic versioning in this way, so anything that looks like a minor change might actually turn out to be a breaking change, where suddenly some of our tests fail, or suddenly we see some incompatibility between these 2 libraries that we didn't realize was going to happen, and now we have to roll that back and then only upgrade some of them and then try that and see if these work with this, and it just always takes longer, even though at this point we have way more Elm code than we have legacy JavaScript code. Just going through and doing the legacy JavaScript upgrades is always more painful because, again, this is not something that you can get without language level support for it. There's no way NPM could mandate semantic versioning just because the language is not equipped to do those kinds of comparisons to automatically tell if you've made breaking changes or not. It's really not achievable. Okay. So those are a lot of the benefits. So let's talk about some of the concerns, because I mean, I think the reason that not as many people have had the experience of introducing a new language is that there are very legitimate concerns about doing so. So I would say the biggest one is like sort of the broad picture here is like, what if we adopt it and it just doesn't work out? Like whatever the reason, we try it out, we make this investment, and we end up saying, yeah, we regret that. We want to go back and go back to something more mainstream. Well, the worst case is like you have to rewrite it, right? Whatever you did, you have to go back and rewrite it in something else. You chose Go, it didn't end up working out, you have to go back to Java. Whatever the case may be, rewrite is sort of the worst case of what can happen. I talked to a company that was working with, I talked to somebody who was working at a company where they had been doing this user interface in some desktop client application. They wanted to go web. And this person was saying, hey, I think we should use Elm for this. And at the company, they said, yeah, but here's the thing. Like, we've been maintaining this client-side thing for like 20 years. We don't want something that's maybe only popular right now. We don't want something that's like the cool current thing. We want something that's stable. We want something that's we're not going to have to rewrite in 5 years. And I totally get that. That's a totally reasonable thing, right? It's like their conclusion was we are going to go with React. And I mean, if you look at like the popularity, I mean, React is like the first thing in decades to be more popular than jQuery. It's like pretty obvious that that's kind of a safe choice, you know, among the options out there today. If you're thinking about like, what are the odds that I'm going to have to rewrite this? Fair enough. Okay, but let's do a thought experiment here. How would this have gone 5 years ago? Like, if you rewind time 5 years and ask this question, like, what technology do I choose such that in 5 years I won't have to do a rewrite? What do you conclude based on the information you had back then, and then how does that end up playing out? Let's take a look. By sheer coincidence, there's an article about this from almost to the day 5 years ago, April 15th, 2013, the battle of modern JavaScript frameworks, modern as of 2013. Here is what the 4 modern JavaScript frameworks they talked about back then. Backbone.js, Knockout.js, Angular 1, and Ember. So for those of you who are not familiar with the front-end world, Backbone.js, nobody's building new stuff in Backbone. Knockout, nobody's building stuff in Knockout. Angular, nobody's building stuff in Angular 1, because when they came out with Angular 2, they changed it so much that many people have said that it was unreasonable to continue calling it Angular because it was essentially a completely different system. So 3 out of the 4, including, by the way, the most popular 3 out of the 4, if you had chosen any of them, I'm sorry, but you ended up having to do a rewrite in 5 years anyway if you wanted to stay current. The only one of the 4 was Ember. So you had a 1 in 4 chance if you threw a dart. Ember is still, as I understand it, basically still something that you can upgrade to today, and if you used Ember this entire time, it remained a reasonable choice. But Ember is not the most popular, or even the second most popular. It's like kind of still a relatively minor player. So if you chose Ember, maybe you would have ended up being happy with it for the entire period, in which case that's totally reasonable, but you can't say that it was the most popular. And if you'd made that same decision that you're making today of choosing React based on its popularity, that wouldn't have led you to the thing that ended up surviving this period anyway. So to me, I think saying we want something that we won't have to rewrite in 5 years, it's understandable, but ultimately it's just an unrealistic expectation. I mean, if you look at the environment, you look at the history of this, there's not a lot of good historical evidence that using this as your algorithm for making technology choices is going to lead to the outcome that you want in the context of front-end development. More realistic expectation is to say we want something that'll just serve us well for 5 or more years. Like, we want something that we can use and be happy with, even if it's not the most popular thing in the next 5 years. That would have potentially led them to Ember, which would have actually achieved their goal of not having to rewrite in 5 years. And I think also that would be a reasonable choice for Elm right now. I mean, we've been using Elm for 3 years. It's definitely not the most popular thing. Clearly that's React. Elm's not even the second or third most popular thing. But we love it. We're extremely happy with it. And you really couldn't pay me. I'm sure there's some amount of money that you could pay me. Like past a certain point, everybody's got their price. But I mean, the amount of money you would need to pay me to switch to a React job or an Angular job or an Ember job from Elm is just a lot higher than I'd be willing to say on stage. Okay, so let's talk about risk and reward, though, because you got these benefits, you got these concerns. They're both real. The benefits are real and the concerns are real. So ultimately, the way that you balance them has to do with the relative risks and the rewards. So Iron talked about this. They said when we first decided on Go, it was a risky decision. And they weren't kidding, because they were really early adopters of Go. When they posted a job listing on the Go mailing list, that was the first time anyone had posted a Go posting on that mailing list. Yeah, very, very early adopters. Definitely a risky decision. As it turned out, they liked it, but it might not have gone that way. Now, an important thing to recognize here is that management cares about risk. I mean, a lot of times people will talk to me and they'll say, hey, how do I convince my boss to let me use this technology that I think is going to be really great at work? I want to use this new language. How do I convince them? And basically, I don't try to sell them, well, here's how to sneak it in there. Here's how to like convince your boss and like sell them on this thing. It's more just to understand like, what does your boss care about and why? And one of the big things they care about is risk. And guess what? That's part of their job. Like if things go south, if you do a big project and you invest in it and it doesn't go well, they're the ones who are on the hook for that at the end of the day. So it's their responsibility to care about risk. And yeah, to balance the rewards against that risk. Some managers are going to be more risk averse than others. Totally true. But you got to understand that they care about it because it's their job to care about it. They should care about it. So what you don't want to do is you don't want to choose a high-risk project to introduce this new language. So for example, an important new like customer-facing feature. You don't want to say, you know what, that big project you talked about that's going to be so amazing, we're going to do that in this new language. Really, really want to avoid that if you can do that. Because think about it. If you got this new feature and your boss is like, yeah, I promise we're going to ship this, it's going to ship on time, which it never does, but you know, you're going to try and ship on time anyway. It's really important to the business. If it doesn't succeed, it's going to have serious consequences for the business. We're going to bet that on this technology that we've never used as a team before. That's super risky. That's like taking a risky thing and just pouring gasoline on it and making it even riskier. Like, really don't want to do that as your first foray into this new language that nobody on your team has used together as a team before. The other extreme is the summer intern project. I talked to one company where they had used a new technology, a new language, and by they, I mean they hired a summer intern. The intern said, can I do this in this other language? And they said, yeah, sure, knock yourself out. And then summer intern left because the summer ended and nobody knew how to maintain it anymore. So they ended up having to rewrite it. I mean, of course they had to end up rewriting it. Nobody on the team knew that language. They didn't bother to have the intern ramp them up because it's the intern's project. I'm not going to learn from the intern. So this is a very predictable outcome. I mean, if you have a summer intern introducing the language and then they leave, well, then nobody knows how to use it. You're going to end up with something that you can't maintain, probably going to end up rewriting it. So also not a good project for kind of the opposite reason. And then finally, don't do this as a rewrite of reliable code. So if you've already got this like big part of your system and it's like working really well, you're like, cool, that's already working well, but maybe it'll be even better if I rewrite it in this new language. Because here's the thing, every rewrite comes with regressions, 100% of the time. You're never going to have a rewrite and have no regressions. I've never heard of that. So you're going to say, well, wait a minute. So you're telling me that we went from a reliable piece of code that we had no problems maintaining to a different piece of code that you said was going to be better, except now it's got bugs. How is this an improvement? And they're going to be right. it's really not an improvement. Okay, so what are some good low-risk projects that we can do instead, that are better ways to introduce a new language? Internal admin tool, something where the customer, like the end user, are people on your own team. Much better choice than a critical external user-facing thing. Because number one, your own people are going to be much more tolerant of mistakes, of slowdowns, of delays, of bugs, of things like that just come from just the normal stumbling blocks of ramping up on a major technology change. Number two, an internal admin tool, the stakes are a lot lower for failure. If you end up having this tool that doesn't work, the consequences are your own team's productivity is diminished, but maybe some of your productivity boosts from using this different language can maybe even make that a wash. Number three, an internal admin tool doesn't have the visibility outside the engineering team or outside the internal company that an external customer-facing thing has. If this project ends up going south, it doesn't like hurt your company's reputation. It just means you lost some time that you're going to have to make up some other way. Another way is a small part of one system. So this is how we did it with Elm. We got this started by making one part of one page go from JavaScript to Elm, because Elm does JavaScript interop. We just had them talk to one another, and we just grew it from there, incremental adoption. On the back end, you can do this with services, or even just with sockets communicating to an existing language. Set up like a really small service, just something really basic, one server, and then have one of your existing services talk to it. Or if you don't have a service-oriented architecture, maybe this is the start of one. You have a monolith and this one tiny service in a different language, and have it just talk to your existing system. Just one small piece of the system. And the key part there is that the smallness is how you get the risk mitigation. So if I spend a week on this small project, I'm just like, I'm going to take this thing, I'm going to get it into production. We're going to start using Elm in production, which is basically what we did. If at the end of that week the project didn't go well and you're like, oh, well, we learned this was a lot harder than we thought. Well, all right, well, that's the end of that. You only lost a week, right? That's a very different pitch than saying we're going to bet this whole new 6 to 12 month project on this. A week is like, look, if it doesn't go well, I'll rewrite it in like 2 days in the technology stack I'm already familiar with. Like the potential costs of failure are just super low because the rewrite is not expensive when it's really, really small. And then finally, rewrite of brittle legacy code as opposed to reliable legacy code. If you've got some code where you're like, this code is a swamp, nobody wants to touch it, when they set foot in it, like dragons come out, like you just don't go to that part of the code base. And if you want to rewrite it in anything, that would be an improvement. The reason this can be potentially beneficial is usually when you have code bases like that, nobody wants to touch them. Like, not just because it's risky to do so, but because it's miserable to do so. And so you can use this as an incentive to end up clearing out a bunch of technical debt that's otherwise going to be really, really hard to deal with. If I'm like, hey, do you want to come and like spend a whole bunch of time going in and tinkering with the worst part of our code base that everyone hates? You're like, no? Why would I possibly want to do that? That sounds awful. But it's still important, right? That technical debt is still hurting the team. If, on the other hand, you say, hey, you know, like you want to use this like awesome new language that you're really excited about, what if you rewrote that awful system in this new language? Now suddenly you have like, well, I don't really want to touch that code, but wow, I super want this. And so like, yeah, on balance, that actually sounds like a really cool project. And like we've had success with that too, of being like, hey, this is like a way to like get a 2-for-1, is to say like we end up with more robust, maintainable code. And yeah, like I said, there's going to be regressions, but guess what? This thing's a giant pile of regressions anyway. So we're going to end up with the code in a better place, a more maintainable place, and we've successfully done the experiment to find out if the language was worthwhile, worth keeping around. And at the same time, we took care of a big chunk of technical debt that otherwise we would have had a really hard time getting anyone to do. So these are low-risk projects. Aim for these when you're doing the incremental adoption thing. This is the way to minimize risk. Your manager cares about risk. They should care about risk. So when you're choosing a project to get started with the language, choose something that's going to let you incrementally introduce it and minimize that risk. Okay, so let's talk about hiring and onboarding. So retaining great people is kind of like the first ingredient to hiring. If you hire people really successfully and they leave after a week, no good. So retaining is sort of an integral part of hiring. And happy programmers, believe it or not, quit less often. This is like kind of a straightforward maxim. But it's also true that if you want great people to stick around at your company for years and years, like I've been at Neurodink 4.5 years, this is the longest I've been with any company. I mean, look, great programmers want to grow. Like it's really kind of a hard pitch to say, hey, will you stay at this company and continue using the same technology for the rest of your career? I mean, that's how you end up being a career COBOL programmer. Nobody wants to say, like, I'm just going to keep doing the same thing year after year if they want to be a really great programmer. So yeah, great programmers do want to grow, and guess what? That means that you have to try new technologies sooner or later. Eventually, if you can't provide that for them, you can't provide that opportunity for growth, they're going to go to a different company where they can have that opportunity for growth. So the impact on team morale, separate from retention, can just be like incredibly, incredibly high for a programming language. This is not a quote from somebody at my company. This is somebody else who adopted Elm, and they blogged about it. I like Elm because it makes my life simpler. It's a joy to use. I'm just more productive. Rust is just a lot of fun to use, a quote from another company. This is one of the Iron.io people. Like Ruby, Go is fun. And it sounds like kind of a silly thing to say like, hey, I want to use this language because it's fun. That sounds almost childish. But think of it in terms of retention. I want to use this language because it's fun. If we're happier at work, less of us are going to quit. That's going to be less turnover, better for retention. That's better for the business. Again, if you want to speak manager, you can say instead of this is going to be fun, you can say this is going to lower turnover. This is going to improve retention. And it's true. It will. Okay. And as with the library framework language trade-off, it's just kind of the same thing when it comes to joy. Like library, minor commitment, but very minor potential joy. Not very often do you hear, I'm super excited to go to this company because the charting library they use is just like unbelievable. I would just be so happy using that in my day-to-day. But with programming languages, you actually do hear this. Like you hear people going to companies because they want to use a particular language, or staying there because they're so happy with this language that is hard to find elsewhere. Which brings me to the hiring paradox. So Iron.io expressed this in a way that I think is really resonates with me. They said, we weren't sure if we would be able to hire top talent if we chose Go. Like I said, they were the first post on the Go mailing list for posting a job offering. But we soon found out that we could get top talent because we chose Go. Top-tier developers wanted to work for us just so they could use Go in their day-to-day lives. This super resonates with me because this is basically the exact same thing that we've heard at No Red Ink over and over and over again. People they want to come work for us because they can use Elm. You can go anywhere in the world and find 1 million React jobs. If your company is like, we're going to go hire a React developer, it's like, good luck, you and everybody else. If you post your React job, you say, come use React and Redux. Imagine it. I mean, who looks at that and says, oh yeah, that's, wow. But where else can I get that? Only every other search result, in the entire world. But if you got someone who's like, I'm pretty keen on Elm. Like this sounds pretty cool. There's not a lot of places you can go and do that, right? Same thing with Java and Go. If you want to get a Java job, yeah, there's 1 million of those. You have no problem finding one. But if you're like, I want to use Go, like how many companies are actually hiring for that? It's a much smaller pool. So our experience has been that Elm is the #1 reason that engineers apply by a huge margin. Like if you look through our cover letters for letters E, L, M, like it's all over everything. We hired a head of talent, and I was like explaining to her when we were in the interview process, I was like, yeah, we use this language called Elm, and we get a lot of people who want to apply because of that. And she was like, oh, okay. She didn't know. Like she's like, this is like I've never seen an inbound pipeline this strong in my entire career. Like she's just like, this is not a thing. Like companies are supposed to have trouble getting applicants. Like you just people just apply. And basically because our whole MO is we just use this language that not a lot of other companies are willing to take the risk to adopt or willing to make the commitment to adopt. And that just makes us part of a much smaller pool. And all we have to do is just make that known. We go to conferences and say, hey, we're hiring, and we hire remote. That's it. And then people apply. Some people in this audience are going to apply just because I said those words and they've been thinking about Elm all weekend. Happens every time. It's really, it sounds like an oversimplification, but it's not. It just is that simple. But I will say there's a caveat here, which is it's different for local positions. So we do a lot of remote hiring. I work remotely for No Red Ink. We have most of our engineering team is remote. But for a lot of companies, it's the other way around. A lot of companies are either primarily or completely local, like on-site work. And there you are more geographically limited. So you might not just like physically have enough people that by coincidence in your area are interested in this particular new language that you're going to adopt. And this is an important thing to keep in mind if you're expecting to get this hiring benefit from adopting the language. So Pacific Health Dynamics, based out of Sydney, they wrote, there's not a large pool of potential candidates for Elm in Sydney. However, the quality of candidates seems to be higher, so we've been fortunate enough to fill our current needs. So their feeling basically was that there aren't a ton of Elm developers or people who want to become Elm developers in Sydney relative to how many there are for JavaScript as a whole. But they found that on average the caliber was higher, and so they were able to fill their hiring needs, but they felt like they kind of got lucky. So if you're working in a much smaller city or a much smaller town than Sydney, maybe that's not going to work out. Maybe you cross the threshold where there just physically aren't enough people who happen to be interested in that technology that it makes up for the gap in what you would see from a more mainstream technology. So something to consider, remote versus local, it definitely makes a difference. Okay, let's talk about onboarding. So WhatsApp basically summarized their approach to onboarding people onto Erlang as, our strategy around recruiting is to find the best and brightest engineers. We don't bring them in specifically because the engineer knows Erlang. It's not a factor for them. They don't expect them to know it. They don't really care. They said, we expect the engineer to come in and spend their first week getting familiar with the language and learning to use the environment. If you hire smart people, they'll be able to do that. I mean, really, this paragraph could apply to any company, like whether they're using an unusual programming language or not. I mean, really, if you think about it, when you start a new job, the biggest thing you're going to have to learn is the code base. Regardless of technology choices, everybody's got a different code base. There's always going to be an onboarding time. So the question is, what percentage of that onboarding time is going to be actual language-specific stuff as opposed to framework stuff, library stuff, just stuff that's homegrown in the code base itself? Well, in our experience, it hasn't actually been that much. So for that reason, you'll never see us posting like must have 5+ years of experience in Elm. First of all, Elm's about 5 years old. So if we had this, we'd be like, must have been around for the creation of Elm, I guess, which wouldn't be likely to work out for us. There's the old, must have 20 years of SQL Server 2013 experience, stuff like that. So we don't do something like this. Instead, we just say, like, look, you must be willing to learn Elm. Like, you have to be willing to come and say, like, yeah, I'm open to learning this new language if I work here. And then that's part of the onboarding is you learn Elm. So how long does that take? Well, we've hired multiple people who came straight out of a JavaScript bootcamp, and in one case, a Python bootcamp, just had never done front-end development. We hire them. This is their first job at NoRed Inc. Like, NoRed Inc. is their first programming job. They're writing production Elm, their first week on the job. We've done this over and over again. Like, it's just not a big part of the ramp-up time. Like, learning the ins and outs of our database schema is often a bigger ramp-up time than just getting productive in Elm. Now, mastering the language, of course that takes longer. Like, becoming an absolute expert, sure, no doubt. That definitely takes longer. But getting to the point where you can be a productive contributor to the team, it's not that long. Now, granted, this will vary by language. I can say this about Elm. I don't know if I can say that about Prolog. I don't know Prolog. Maybe Prolog's learning curve is really short, maybe it's really long, but all I know is that for languages in general, it's definitely achievable to have something like what we've had and what WhatsApp has had, where it's just like, yeah, that's just part of your onboarding, it's just not a big deal. I think people think this particular thing is going to be a much bigger deal than it actually is in practice. It's one of the areas where the risk and reward, I think, is sort of skewed in terms of people's perceptions. Learning on the job is just a sort of normal part of having a job and starting a new job. Okay, so to summarize all the things we talked about a bunch of stuff. Big picture, library, minor commitments, minor benefits, all the way through to programming language, major commitment, major benefits. We talked about some of the technical benefits, talked about reliability, all the uptime that Ericsson had with Erlang, 9 nines of reliability. NoRed Inc., like essentially no runtime exceptions compared to like 60,000 from JavaScript over the same period of time. Talked about productivity benefits in terms of people being able to get stuff done faster, fearless refactoring. We talked about reduced costs, Iron.io going from 30 servers down to 2, and even those 2 were way over capacity. We talked about organizational benefits in terms of morale, people being happier at work, having less turnover, higher retention, just because people are happier using the technology they're doing day to day. Talked about the impact that has on retention and how that's kind of the part of morale that managers often care a lot about. Talked about impact on hiring pipeline, how there's actually this paradoxical thing where if you're one of the few companies offering this technology that a lot of people want to get on, that can actually be a benefit from you from a hiring perspective, or potentially even like has been for us and for Iron.io, the #1 reason that people apply. We talked about risk and reward. We talked about like what are the odds of a rewrite? Maybe it's higher than you think. If you think you can pick a technology that's definitely not going to require a rewrite in 5 years, maybe you ought to think about, look at the historical data. Is that actually supported, or are your odds not that good regardless? Talked about incremental adoption being kind of key to minimizing risk and maximizing the chance that the new project is successful. We talked about high risk and low risk projects. What kinds of projects are potentially high risk and should be avoided as ways to introduce a language versus low risk projects that are much higher chance to work out. Finally, I'm writing a book, Elm in Action. If any of this stuff has sounded interesting to you, this is a shameless plug for that. Or another good way to learn Elm is I taught a course on front-end masters. So if you subscribe to them, that's a good way to learn it too. Thanks very much.